A set in Dart is an unordered collection of unique items. There's really two key ideas there. One is the unordered collection part. That means, unlike a list in Dart, there's not going to be an index position you can reference for the items inside of a set. They're stored in a essentially lookup efficient manner, essentially behind the hood or underneath the hood. There's a little bit of math going on. That's why they're unordered, but it's quicker to retrieve them, technically speaking. And they're also unique items. So what that means is you can't add the same item more than once into a set. And Dart support for sets is provided by set literals and the set type. The thing to remember is that, again, the collection of items are unique, meaning you can't add more than one instance of a value. This feature can then actually be very useful for quickly comparing the union of sets or the intersection of two sets. Let's take a closer look at sets inside of DartPad. Inside of DartPad, let's start by creating a set and show you the syntax for it. So a set, if we create a new variable called elements, remember, it's a collection of unique items. So it's going to make most sense when you can only have like one instance of an item inside the set. For example, if I'm making a set of elements like the actual elements like oxygen or potassium or nickel or rhodium, those sort of things, it makes sense that there's only going to be kind of one instance of each inside of my set. So we use curly braces and then separate out the items with commas. So it looks a lot like a list, except instead of square brackets, you're using curly braces. So then what I can do is I can add items to a set. To do that, you just grab your set and then add the item you want to add in. For example, I can add in another element there. I think that's fluoride. Or I can add in an entire list or another set. So if I wanted to add more elements, in fact, let's just print out elements here so we can see what it looks like before adding things. In fact, let's print it out all 3 times. So I'm going to print it out at the beginning. I'm going to print it out after adding a new element to it. And then let's print it out after adding a list of elements. So we'll say elements dot, and then I can hit add all, and that's going to be able to take in something I can iterate across. So for example, it wouldn't be uncommon to add everything from a list to a set. So hydrogen and carbon, add those as well, and let's print out the elements. So we're going to print this out 3 times, the original, adding a single, and then adding everything from a list into the set. So here's our original set. Here it is added with F, and then here it is again with added F, and then added H and C, those elements. Now what happens if I try to add in C again? Will it be represented twice? No, because it's a collection of unique elements, which means it doesn't matter how many times I say something like add C, you're not going to see a difference when you actually end up calling for elements. So run this again, and you will notice essentially no change from adding HC and then trying to add C again. Again, it's only for unique elements. So that's really useful in instances where you know there should only be one instance of a particular value, and then you can store those. That leads you to unique abilities to check for the intersection of things within sets. So for example, you could have one set with a certain group of students and another set with another group of students, and you want to see what students are in both sets. That's known as an intersection. You can also do things like the union of sets. Now, I don't want to dive too deep into that because we're actually going to test you about that idea in the next lecture. So think about this idea before you go into the next exercise lecture. If you have set 1 and you have another set 2, what would the intersection of these 2 sets mean? Well, it would mean the items in set 1 that are also inside set 2, or unions and set intersection. So let's imagine we have 2 sets. I'll represent them by circles. In one set, I have the items A, B, and C. In another set, I have the items X, Y, and C. Now, I can have a union or an intersection of these 2 sets. Let's discuss the difference between them. A set's union is going to be all the items put together from both sets. Now remember, sets can only contain one instance because they're an unordered collection of unique items. That means even though the letter C, as in Charlie, is found both on the left-hand set and the right-hand set, the union between them is only going to include it one time. But you'll notice it includes the letters from the other sets as well. So the union of these 2 sets is A, B, C, X, Y. Now let's take a look at if I wanted the intersection between these 2 sets. Sets intersection is going to be only the items that happen to be in both sets. So if you take a closer look at this, now you realize only the letter C for Charlie is in both. That means the intersection is going to be a set that only consists of C. With that being said, let's head over to your exercise. So here's your exercise. Let's imagine I have sets of students. I have a set of students for the football team, which includes Andrew, Zach, and Calvin. There's also a cast for a school play. That's David, Calvin, and Claire. Can you figure out how to use the intersection method with sets in Dart in order to figure out the students that are both on the football team and actually in the school play? Again, I'm not asking for all the students. I'm only asking for the one student that happens to be both on the football team and cast in the school play, which by eye you can see is Calvin. So that should be your result. Okay, I'm going to go through a solution now. I'm going to pause the video here if you want to try it yourself. Let's go through a solution in 3, 2, 1. So the solution is pretty self-explanatory. There's actually literally just a method called intersection. So you grab one of these sets, like football team, and then check its intersection with another set object, and that itself returns a set, as you can see here from the documentation. So here we can just pass in playcast. Whoops, that should go into here, playcast, and then semicolon. Go ahead and run this, and we should see it print out a set that only includes Calvin, since he's the only person that's on both the football team and playcast. And something to note about intersections is it doesn't actually matter what order you put them in, since it's kind of this idea of symmetry. It didn't really matter what order those circles were in. It's going to be the same thing either way. So you couldn't call playcast, and then grab the intersection there and pass in football team, and you would get back the exact same result. So if you run this, you'll just see a set of Calvin twice. Okay, that's it. That's how you can grab the intersections between two sets. We'll see you at the next lecture.